Rust inhibitors work by forming a protective barrier on the surface of metal to prevent or slow down the oxidation process, which is commonly known as rusting. Rust inhibitors can function through various mechanisms. Barrier protection. Rust inhibitors create a physical barrier between the metal surface and environmental factors such as moisture and oxygen, which are necessary for rust formation. This barrier prevents direct contact between the metal and corrosive agents, thereby inhibiting oxidation. Chemical reaction. Some rust inhibitors contain chemicals that react with the metal surface to form a protective layer. For example, certain inhibitors react with the metal to produce a passivation layer of oxide, nitride, or other compounds that are more resistant to corrosion than the base metal. Adsorption. Rust inhibitors can adsorb onto the metal surface, forming a protective film that impedes the access of corrosive agents to the metal. This film can be chemically or physically adsorbed, depending on the nature of the inhibitor and the metal surface. Inhibition of electrochemical reactions. Rust inhibitors can interfere with the electrochemical reactions that drive corrosion processes. By altering the electrochemical properties of the metal surface or the surrounding environment, inhibitors can inhibit the formation of corrosion cells and slow down rusting. pH control. Some rust inhibitors work by controlling the pH of the environment surrounding the metal surface. By maintaining an alkaline or neutral pH, inhibitors can reduce the rate of corrosion by stabilizing the metal surface and inhibiting the formation of corrosive compounds. Overall, rust inhibitors employ various mechanisms to protect metal surfaces from corrosion by forming protective barriers, chemically reacting with the metal, adsorbing onto the surface, interfering with electrochemical reactions, or controlling the pH of the environment. The effectiveness of a rust inhibitor depends on factors such as the nature of the metal, the environment in which it operates, and the specific mechanism of action of the inhibitor.